looking at 1A.2 master learning objective, I can determine a dilation by identifying the center and the scale factor to prove the triangles are similar. Okay. So we're looking at our fourth type of transformation today. So we've looked at translations, reflections, and rotations, and now we're going to be looking at dilations. So a dilation is a type of transformation that reduces or enlarges objects. Okay. We have the scale factor, which is represented by the letter K, right? And that describes how much the figure is enlarged or reduced. It's a number, okay, that will tell you if it's doubling in size, it's going to be 2. If it's being cut in half, right, it'll be half. The corresponding side lengths in a dilation are what we call proportional, and that's going to come up a lot more in our future targets, not so much in this one. To find a scale factor, you divide a side length of the dilated figure by the corresponding side length of the original figure. Okay? So you divide your image by your pre-image. If K is greater than 1, the original figure has been enlarged. It got bigger. If K is between 0 and 1, so less than 1, the original figure has been reduced. If K equals 1, the original figure is congruent. Okay? So that just means they're the exact same size. All right. So we want to find the scale factor. So I'm going to do the same thing I did before. I'm going to figure out which one's the pre-image and which one's the image. Music is really loud. Right. So again, the one with it's A, B, C, 2, A prime, B prime, C prime. Your first one's your pre-image, your second one's your image. This scale factor equals I over P. Okay? So I'm going to choose one side of I and divide it by one side of P. So you can choose any side. It should just be straight up and down or straight across. So I could choose this side or this side. Don't choose this one. You can't just count. Okay? So choose your straight side and then choose the same side in the other figure. Okay? So image over pre-image. How long is this one? 1, 2, 3, 4. Your pre-image is 1, 2. So your scale factor is 2. And then is this an enlargement or a reduction? Or are they congruent? Well, 2 is bigger than 1. So this is enlargement. That also makes sense because we started here and went to here. The shape got bigger. And you should be able to see that as well. Looking at example 2, my pre-image is this one. Right, the one with my primes is my image. I'm going to just choose a side on both of them. My scale factor is I over P, image over pre-image. 1, 2, 3. Divided by 1, 2, 3, 4, 5, 6. Which equals 1/2. Since 1/2 is less than 1, this is a reduction. Looking at example 3. I'm going from A, B, C, so that's my pre-image, to D, E, F, that's my image. So my scale factor equals I over P, image over pre-image. Again, I'm going to choose a straight side, which is these. So my image is 1, 2, 3, 4, 5, 6 units long. My pre-image is 3 units long. So my scale factor is 2. From here to here it is getting bigger, and this is greater than 1. So both of those things point to an enlargement. And then example 4, ABC has been dilated to produce A prime, B prime, C prime. Our scale factor equals I over P. I'm going to choose a straight side. A to B is straight, and then A to B is straight here. It's okay that it's changed. Okay, we still have to match up those sides. It's okay that it's been rotated. We can still find our scale factor. I have 1, 2, 3, 4, 5 in my image. 1, 2, 3, 4, 5 in my image, or my pre-image. 5 divided by 5 is 1. So this is not getting bigger or smaller, it's stayed the exact same size. This is congruent. All right, looking at example 5. Okay, so now we are going to do an actual dilation. Graph the quadrilateral J prime, K prime, L prime after a dilation with scale factor of 2, centered at 0, 0. So I have J, K, and L. J is at 2, 1, 2, 3, 4. K is at 1, 1, and L is at, goes over 4, and then did not move up or down. So now I want to graph my dilation with a scale factor of 2. All I'm going to do is multiply all my points by 2. Okay? 2 times 2 is 4. 4 times 2 is 8. K prime. 1 times 2 is 2. 1 times 2 is 2. Sorry. 1 times 2 is also 2. Why? Hold on. Okay. Let's hope this works. Now something you're right. There we go. Okay. And then finally L prime, 4 times 2 is 8. 0 times 2 is still 0. Okay. So now I actually have to graph these. J prime is at 4, 2, 3, 4, 5, 6, 7, 8. That's J prime. K prime is at 2, 2. And then L prime is at 8, 0. And then I, again, do connect them. And that is my new triangle. And again, you should be able to see right away if you did it incorrectly or correctly. Again, it should just look like a larger triangle. Shape, orientation, all that stuff is still the same. All right, let us look at example 6. Graph KLP with vertices at -4, -6. L at 0, 4. And P at 4, -6. So -4, -6 is here. That's K. 0, 4 is here. That's L. And 4, -6 is here. That's P. KLP. Okay. Now I am I have a scale factor of 3/2. So I'm going to multiply all of these by 3/2. If you struggle with fractions, no worries, use a calculator. All right, -4 times, -4 times 3/2. You can just write 3 divided by 2, and we get -6. Okay, so don't be afraid to use a calculator, especially when we have like fractions. I know those can be confusing. Okay. For the rest of the numbers, I'm just going to do them. I assume we know how to work a calculator. If you're having trouble with a calculator, just let me know. -6 times 3/2, you get -9. Okay. L prime, 0 times 3/2 is 0. 4 times 3/2 is 6. And then finally, P prime, 4 times 3/2 is 6. -6 times 3/2 is 9. Okay. So I'm going to graph these new points. K prime is at -6, -9. L prime is at 0, 6. And P prime is at 6, 9. Wow. Lost my... I'm going to connect all of these. For our new triangle, again, you can see that it just got bigger. So, what do dilations change? Well, the biggest thing we notice that they change is size. They also technically change position. Those points are moving around, so they do change position as well. Alright, that is it for 1A.2, a shorter video today. I will see you guys tomorrow, and we will work on our 1A.2 activity.